Hey, we're starting chapter 2. Actually going to combine the first two sections. They're pretty much the same thing, just the equations are very slightly different. So 2-1 and 2-2. 2-1 is all direct variation. 2-2 is inverse variation. Just want to start out talking about the difference between the two. So direct variation, kind of my shorthand for it is something's directly related when if one variable goes up, if x goes up, then y goes up. For example, the amount of time, you could say time x is going to be the amount of time it's been since you had your last haircut. Y then would be the length of your hair. They're directly related. It's been longer since you had your haircut. Your hair is going to be longer. Same thing then would be if one variable goes down, the other variable has to go down. If it's been less time since you had your haircut, your hair typically is going to be shorter than if you had more time. So direct variation, when the variables are going to do the exact same thing. The general equation is going to be y equals k times x to the n. And I want to make a couple comments about that. One, you can see that now if you have a math equation like this, if x gets bigger, y is just naturally going to get larger. It just happens that way. So that's one thing, shows you how it's direct variation with multiplication. K is going to be a constant. And that tends to mess with some people's heads. One, why K? Why not C? Well, C stands for the speed of light, so it's kind of reserved, so I'm assuming that's why they went with a K for the constant. But that's called the constant of variation. And sometimes that's easiest just to look at it, so that's going to be a number that makes the units work out right. For the hair example, not everyone's hair grows at the same rate, so someone whose hair grows really fast is going to have a larger K value. If X is the number of days, then K has to be bigger for them. Or if X, instead of being measured in days, was measured in hours or months, K then would be a constant that would fit kind of that unit to make it so it works out for Y, because 30 days, 1 month, you'd have to have different K values to get the length, the Y values to be the same. The N, if you think back to the last chapter where we had like T sub N or A sub N had to be a natural number. Same sort of thing here. So N is going to be an exponent, and it's going to be a number like 1, in which case we wouldn't write it in, or 2, or 3, or dot dot dot. So it could be y equals kx squared, y equals kx, y equals kx to the 17th. It's going to be some number with no decimal. This equation here is important. We're going to keep coming back to writing equations in that sort of a format. Jumping down to inverse variation. So inverse variation, now the chapter 2, section 2. So if your homework is just from section 1, you won't be doing these yet. But things are going to be inversely related if x and y do opposite things. So now when x gets bigger, y has to get smaller. Or if x gets smaller, y has to be larger. So an example for the inverse variation that makes sense to me at least would be if you go scuba diving, you have a certain amount of air. And once you use up all that air, you better be on the surface. So inverse variation would be the amount of time you can spend underwater and how many breaths you're taking per minute. People that are new at scuba diving, they tend to swim really fast everywhere, they breathe really quickly. So if x, their number of breaths per minute, goes up, y, their time underwater, is going to be less. So the general equation that you're always going to use for the inverse variation ones are going to be y equals k divided by, now the x to the n. Because if you have a division problem like this, now you're going to have it be where when x goes up, y is naturally just going to go down. And this next thing is going to be writing formulas. That a lot of the problems they have you be able to write out the mathematical equation given a story problem. So just want to do a couple of those. You could try to copy these down. You might want to just kind of watch, follow along, and I'm guessing most of you will get it. So 3 examples. Pause it if you want, quick write them, whatever. So y varies directly as the square of x. First thing is we have to have a k. If we go back to our variation equations, that's going to be the most common mistake on this first quiz, is people forget to put in the constant. So this first part, the y varies directly, that tells you a bunch of things. Well, one, it's going to be y equals, so the y varies. We know there has to be a k. Whenever you have direct variation, you know it's multiplication. So just those 3 words alone tell you y equals k times. Square of x gives us an x squared. Y varies inversely as the cube of x, so y varies again, so y equals k. Inversely means we have division, and cube would be third power, so it'd be x to the third in the denominator. It doesn't have to be an x and a y. T is directly proportional to r. You could have t equals k, that direct again, so k times r. If they don't say squared, fourth power, seventh power, you just assume it's the first power, in which case we don't write it. Now when you first start out doing the problems, like covering the reading, they're only going to have you do like just write the general formula or just find k. But as we go through and later do like the whole problems, you're going to have these 4 steps that you're going to follow over and over and over and over. So you might want to pause the video, write them down. But the steps to solve the problem, you'll see them in this practice, Roman numeral 5, the example. But first thing, you write the general formula like we just were doing. Then you find that constant. Once you find that constant, you put it back in that original equation you wrote, and then you get the answer to whatever they're asking. So my practice one, a 12-inch pizza costs $7. If cost varies directly as the square of the diameter, how much should a 15-inch pizza cost? So first thing we want to do is this number 1. We want to go and we want to write the general formula. And that's given to us right there. Cost varies directly as the square of the diameter. So cost varies directly, you could say C equals K times for directly. Now we have the square of the diameter, so D squared. And so we did number 1. We wrote the general formula. Now we need to find K. In order to find K, we need to know everything else. K needs to be the only unknown in the equations. We need to find a pair of numbers. What's a cost for a certain diameter? And we have a 12-inch pizza, that's our diameter. Costs $7. So you could put in the 7 for the cost, the 12 for the diameter. Make sure you include your squared. Seen that mistake a couple times. Now to solve for K, we're going to go and divide both sides by 144, or divide both sides by 12 squared. So 7 divided by 12 squared gives me 0.04861 repeating. So K equals 0.04861111111. Mistake that a lot of people make is they round this. They say 0.05, good enough. The problem is going to be when you multiply that by 15 squared, a little bit of rounding ends up giving you a radically different answer. You don't show your work, don't know if you guessed, so you get kind of pounded. A good rule of thumb is to never round until you get to the very end of a problem. When I write it though, I'm going to do some rounding, so maybe I'll put 0.05. I probably should write out the whole thing if you're watching me, but on my problem I probably write 0.05. But then this step 3, where it says take the K, put it back in the original equation, best to write the whole thing. Maybe I should have just stuck with that. But now we say step 4, use the formula to solve the problem. And that's going to be this last part of the question, how much should a 15-inch pizza cost? So if we take the 15 and put it in for the diameter, we have 0.04861 repeating times 15 squared. You could punch that in 0.04861111111 times 15 squared. Technically you rounded because you didn't do an infinite number of ones, but you went to a whole bunch of digits. Easiest though is if you look at your calculator, that number is the last one on the screen. So if you just do times 15 squared, it says answer times 15 squared, and it does it for you. So our 15-inch pizza should cost $10.94. So $10.94 would be the answer to the problem. A couple comments. One, if I had rounded, if I just done 0.05 times 15 squared, my pizza would end up being $11.25. So you'll notice rounding matters. So make sure you don't get caught up rounding before the very end of the problem. Second thing, kind of getting back to what is K. K was that constant of variation. If you're talking about a Domino's pizza versus Uccello's pizza or something like that, K in this case is like the cost per square inch. That's where it gets a little dangerous. If you go through, you can figure out what's the cost per square inch on a small pizza versus a medium versus a large, and then you're like me, you always order the large pizza and have tons of leftovers. But it's just painful to see how much more they're charging you per square inch on a smaller one. So that's kind of what K is. It's something that makes the units work out right if I was measuring in inches versus centimeters or something like that for my diameter. And that's really it for section 1 and section 2. Thanks for watching.